Hi everyone and welcome to the channel. In this video, let's just play some games and prove that this statement here is logically equivalent to this statement here. But now wait a minute. What is the meaning of all this notation? Let's sort it out first. Now, suppose we have a statement P. The negation of the statement P, let's write it here, negation of P is the statement not P. So the negation of statement P is the statement not P. For example, if I say to you that the sky is pink, if I say to you the statement P is the sky is pink in color, then the negation of statement P, which is written not P, is the sky is not pink in color. It's a silly example, of course, but I hope it clarifies the point. Now, the other way is that if I have two statements P and Q, I can combine those statements using either what is called a conjunction, or a disjunction. Now, a conjunction is a statement where we have P and Q. Now, this means that this statement here can only be true if both P and Q are true. That's a conjunction. A disjunction, which is the statement P or Q, is only true when either P or Q or both are true. So here we have P and Q must be true in a conjunction. Here, either P or Q must be true or both. That's for a disjunction. Now, we want to prove that this is equivalent to that. But notice here we have the disjunction of P and Q negated outside the brackets here. Here we have a conjunction of the negation of P and the negation of Q. Now, to prove that this is logically equivalent to that, we need to construct a truth table. This is where we represent true with T and false with F. These are called logical values. So let's construct our truth table. We will have our statement P there and our statement Q there. Let's separate them with a vertical line. Let's write our Q nicely there. Then we are going to have our statement negation of P and our statement negation of Q. Then let's have here the disjunction of P and Q and the negation of this disjunction of P and Q. And then here, I hope it fits, the negation of P in conjunction with the negation of Q. I hope I'm squashing those in a narrow space. I hope you can see that. Now, let's put in the truth values. Right. What are the possibilities? Either T can be true and Q is true. Sorry, P true, Q true. Or P true, Q false. Or P false, T true. Or T false and T false. So those are the scenarios. Let's just make sure we've got some horizontal lines here. It's nice. So we can separate the these things. Okay, so here we are. Okay, now let's look at what's going to happen. What is here? P is true. What's the negation of P? It's false. Here P is true. What's the negation? It's false. Here P is false. What's the negation? It's true. P is false. Once again, the negation is true. Over here, Q is true, so the negation is false. Here it's false, the negation is true. Here it's true, the negation is false. Here it's false, the negation is T. Right. What is the disjunction of P or Q? So true, true, both of them are true, so this one is true. True, false, at least one is true, so the statement is true. Here, false, true, at least one is true, so it's true. False, false, so the statement is false. What about the negation of that? The negation of that, here it's true, so the negation is false. Here it's true, the negation is false. Again, here is true, the negation is false. Here it's false, the negation is true. What about here? Negation of P and negation of Q. So in other words, both must be true in order for this statement to be true. Let's come over here. P, negation of P is false. Negation of Q is false, so it's false. Here, negation of P is false. That one is true. Both of them need to be true in order for it to be true. So again, it's false. Here, we need both. Only one is true. So again, it's false. Here, both are true. So the statement is true. Now, what we wanted to prove is that this is logically equivalent to that. So we have finally proved that this is logically equivalent to that. So the negation of the disjunction of P and Q is equivalent to the negation of P and the negation of Q. Till we'll see you next time. Bye-bye.